Hey everyone, welcome to this explainer. Look, if you're a developer right now, you are definitely using a large language model on a daily basis. But honestly, treating these models like glorified search engines is totally holding you back. Today, we're going to transform your prompt engineering from basic text inputs into a highly structured, super effective developer skill. So let's jump right in.
Here's our roadmap for today. We'll be moving from the baseline of zero-shot prompting right on through few-shot, chain of thought, tree of thought, and role prompting, before finally capping it off by combining all these powers together.
First up, our baseline, zero-shot prompting.
If you've ever fired off a quick request to ChatGPT or Claude, you're likely already doing this every single day. Basically, zero-shot prompting is when you jump straight into a task without providing any prior examples or training to the model. Think of it like asking a trained human expert to do a job by just giving them really clear, specific instructions. You're not holding their hand at all. You're just relying entirely on their pre-existing training to get it done.
Knowing exactly when to deploy this is the key. Zero-shot is absolutely perfect for straightforward tasks where the output format is super clear. You'll want to use this when you just need quick results, no complex setup required, and for tasks the model already understands really well. Seriously, there's no need to over-engineer a prompt if the LLM already knows exactly what to do. Take a standard software review prompt, for example. We're asking the LLM to classify a review as positive, negative, or neutral, and we're demanding that it only gives us a single word. This is a flawless zero-shot use case. The model understands sentiment analysis right out of the box. So if we feed it something like, "The new feature works great, but the documentation could be better," it instantly spits out neutral, super clean, and incredibly fast.
All right, moving to number 2, teaching by example, few-shot.
But what happens when the LLM just isn't grasping the specific format you want? That brings us to few-shot prompting, which is essentially teaching the LLM by example. Instead of just giving it raw instructions, you show the model a few examples of your ideal output, and then you ask it to follow that exact same pattern. You're basically handing it a strict blueprint to follow.
So when do you use this? Few-shot is your ultimate go-to when you need very specific output formatting or when strict consistency across a massive dataset is critically important. Bottom line, if your zero-shot attempts are failing to give you the precise formatting you need, few-shot is your reliable fallback.
Let's say you're dealing with a messy date formatting problem. We want to convert text dates into a strict numeric format. By explicitly showing the model that March 15, 2024 needs to become 1503-2024 and December 1, 2023 becomes 01/12/2023, the LLM immediately locks onto the pattern. Then, when you throw April 7, 2024 at it, it knows exactly what to do. No more hallucinations, just precise, perfectly formatted data.
Number 3, step-by-step chain of thought. Now we're getting into the heavy hitters. Let's talk logical reasoning. Chain of thought prompting is all about encouraging the model to break down complex problems into individual steps. It's honestly just like your grade school math teacher making you show your work. By forcing the model to essentially think out loud, you stop it from rushing into a wrong, hallucinated answer. It actually has to document its intermediate reasoning before it gets to a final conclusion. You are definitely going to want to use this for complex reasoning tasks where accuracy is paramount. It's an absolute game changer for verifying the model's logic and debugging. Think about it. If an LLM gives you a bad output on a zero-shot prompt, you have literally no clue why. But with chain of thought, you can read its logic step by step and spot exactly where it made a mistake.
Let's look at a classic math problem from the text. A store has 120 apples. It sells 30% on Monday and 25% of the remaining apples on Tuesday. How many are left? If you just ask for the final answer, the LLM might easily stumble on the percentages. But instead, guide it step by step. Step 1. Start with 120. Step 2, 30% of 120 is 36. Step 3, 120 minus 36 leaves 84. Step 4, 25% of 84 is 21. Step 5, 84 minus 21 is 63. By forcing this exact breakdown, the model hits the correct answer flawlessly every time.
Next up, number 4, exploring paths, tree of thought. This is our most advanced cognitive framework right here. Tree of thought takes that step-by-step reasoning and scales it horizontally. It builds on chain of thought by exploring multiple reasoning paths all at once. Rather than a single straight line of thought, you're asking the model to actively manage, evaluate, and compare multiple solution branches simultaneously. It maps out options, evaluates them, and aggressively prunes the bad ones. To actually pull this off, your prompt needs to be structured in 3 phases. First, problem decomposition, where you break the problem into key decision points. Second, generating multiple thoughts, forcing the LLM to draft several different approaches for each point. And third, evaluation and pruning, where it critically judges the trade-offs of each branch and cuts the weak paths until it finds the absolute best route.
Tree of thought is absolutely killer when simple linear reasoning might miss the optimal solution entirely. Imagine you're designing a high-traffic mobile app architecture. You don't just want the very first answer that pops into its head. You want the LLM to compare a monolithic database against microservices, weigh out the scalability trade-offs, pick the best one, and then move on to evaluating the API layer based on that previous database choice. It literally maps out the entire decision tree for you.
Number 5. Specialized expertise. Role prompting. Let's move to our final standalone technique, which completely shifts the model's perspective. Put simply, role prompting is when you command the LLM to put on its expert hat before tackling your problem. You're giving the AI a specific persona and asking it to adopt a highly specialized professional background when generating its response.
You definitely want to deploy this when you need a certain level of technical depth, mostly because it saves you from defining a million constraints manually. If you just ask an LLM to check this code, you're probably getting a pretty generic junior-level response. But by assigning a role, you unlock totally different, highly specialized layers of its training data.
Take a standard SQL snippet, for example, by explicitly telling the model to act as a senior security engineer analyzing this code for vulnerabilities, and then feeding it an unsanitized SQL query string. Wow, the AI shifts its whole context window. It's not just looking for syntax typos anymore. It will immediately flag massive SQL injection risks, explain the attack vector to you, and tell you to implement parameterized queries. You get senior-level review instantly just by setting that role. And finally, number 6, combining your prompting powers.
All right, we've reached the boss level of this explainer, combining these individual techniques into one massive, powerful prompt for maximum reliability. As the source material reminds us, good prompting is highly iterative, and these strategies aren't mutually exclusive at all. The real magic happens when you stack them. Imagine combining role prompting specific expertise with Tree of Thought's multi-path exploration. You could say, act as a lead cloud architect, and then have it evaluate 3 different scalable infrastructures step by step. Or you drop few-shot examples right inside a chain of thought prompt so its thinking out loud process perfectly matches your company's formatting standards.
So, we've gone from basic zero-shot inputs to engineering some seriously complex, multi-layered reasoning. I want to leave you with this provocative thought. Now that you've got this highly structured developer toolkit in your back pocket, look at your code base today. Which of your most frustrating, inconsistent LLM tasks are you going to re-engineer first using these combined strategies? Start experimenting, start iterating, and take total control of your prompts. Thanks for tuning in.